Hello class. Today we're learning about the state of matter, okay? And our learning objective is to understand changes in states of matter. Now, before we begin, I want you to ensure that you've got all your equipment with you. Make sure you've got your book with you, you've got your pen, your pencil, your green pen, and your ruler. So I would like you to now pause the video and make sure you've got all your equipment. Okay, can we begin now? So I would like you to write down your learning objective, okay, which is to understand changes in states of matter, okay? So I'm just going to give you a few seconds to actually do that. Again, pause the video, write it, and then when you're ready, press play. Okay, moving on, okay? Now, the next thing I would ask you to do is actually answer this retrieval practice question, okay? Now, it's a what am I question, okay? What I'd like you to do is actually state the name and actually the state, okay? So for example, question 1 is asking you, I have a fixed shape, okay? I have the chemical symbol Fe. I'll need you to write down what Fe stands for, what particular element is Fe standing for, and is it a solid, is it a liquid, or is it a gas, okay? So what I'd like you to do is actually to answer this question. I'll give you roughly 4 to 5 minutes, okay? Again, pause the video, answer the questions, and when you're done, make sure your green pen is ready for you. So pause the video and answer the question. Okay, let's move on. So the first question is asking you, okay, the what am I question. I have a fixed shape and I have the chemical symbol Fe, okay? So what does, now, first of all, let's break this down, okay? The first one's saying I have a fixed shape. So thinking about what we've learned from last lesson, okay? Solid, liquid, and gas. Let's think about how they are arranged, okay? So which of the states have got a fixed shape? And the answer is actually solid, okay? Solid, S-O-L-I-D, state has got a fixed shape. You can literally see that the particles are tightly arranged together and they don't take the shape of whatever container they've got. They actually remain the same, okay? The example I give from last lesson is, imagine a Rubik cube, okay? If we drop a Rubik cube in a bowl, it's still going to be a cube. It's not going to change or form the shape of the bowl, if that makes sense, okay? Now, the second part of the question is saying I have a chemical symbol Fe. So in your diary, okay, in your planner, you actually have your periodic table. And if you look at it, you would realize that Fe actually stands for iron. So I-R-O-N, okay? So it's solid and the chemical symbol represents iron, all right? Good. Now, question 2 is asking you or telling you, what am I? I take the shape of the bottom of the container and have the formula H2O. Wow. Okay. Now, if we think again and look at the different states, okay, which particular state actually takes the shape of the bottom of the container? And I'm sure your guess will probably be liquid. Okay. Liquid takes the shape of the container. Okay. And then you're saying, but I have the formula H2O. Now, for those of you, many of us should be able to remember that H2O actually represents water, okay? 2 atoms of hydrogen and 1 atom of oxygen, okay? So it's liquid and the H2O stands for water, okay? Am I making sense? Brilliant. Now, question 3 says, I flow the easiest and have the chemical formula of CO2. Flow the easiest, meaning it's really, really, really light. Okay, so let's have a look together. Okay, it's made up. Which state actually flows the easiest? Is it solid, is it liquid, or is it gas? Think about it. You might think, oh, it's liquid, but actually it's not really liquid, it's actually gas. Okay, so the first state is gas. Okay, this is gas that flows the easiest, and then the formula CO2 actually represents carbon dioxide. So the word carbon is C-A-R-B-O-N, and then dioxide. Okay, the word di actually represents 2. Okay, so it's going to be Di and then oxide, O-X-I-D-E, if I'm making sense. Okay, so it's gas and it's carbon dioxide. Okay, now question 4 says, I cannot be compressed very easily and I have chemical symbol Cu. Now again, what cannot be compressed easily? Water can be kind of compressed, yes. Gas, kind of. So which one? First of all, it's going to be solid. Solid, remember, has got a fixed shape, so it can't really be compressed as that. Okay, so the answer is solid. And so what chemical symbol is representing Cu then? What is Cu itself? Cu actually stands for copper. Okay, copper. To spell copper is C-O-P-P-E-R. Okay, well done. Now, question 5 says, I take up the shape of the container. I am necessary for all living things to respire. Wow, now that is the real key there. First of all, I take up the shape of the container. Okay, remember, for water, it takes the shape of the bottom of the container. Okay, now what else takes the shape of the container this time and is needed for all living things to respire? When you respire, remember, it's like you're breathing in and out. So what are you breathing in? What are you breathing out? And your answer is gas. Okay, so gas takes up the shape of the container, and it's also required for living things to respire. Remember, oxygen is actually required for living things to respire. Okay, so gas and oxygen are your 2 answers. Okay, well done. Now question 6 says, my particles are close together but move around, and I have the chemical formula of Br2. That actually stands for boron. They're close together but move. That means boron is actually in liquid form. Okay, so I do hope you understood this work. Okay, all right, let's move on. Now, like I said, we're going to be looking at understanding changes in the state of matter, and hopefully we should be able to develop our knowledge of understanding it, and also be able to use different forms of modeling to show changes in state of matter, and also you'll be able to use your knowledge to actually answer a 6 marks question. So yes, you'll be actually attempting to answer a 6 marks question. Now, let's have a look at this. Okay, what I want you to do is actually to match up the words. Again, I would like you to pause the video and match up the words. Okay, moving on. So melting is actually from solid to liquid. Okay, that's the meaning of melting. Okay, if you're looking at change of state, it's solid to liquid. Freezing is actually from liquid to solid. So imagine freezing water to become ice. Okay, that's from liquid to solid. And then condensing, imagine when you're boiling water. Well, that's for evaporation. For condensing, imagine actually a water vapor cooling down. Okay, the word condensing. So it's going to be from gas to liquid. Okay, now evaporating is actually the other way, from liquid to gas. Imagine boiling your water and everything actually changes to gas. Okay, so that's evaporating. And then we've got this word subliming, and that actually stands from change from solid to gas. Okay, now, and this position is actually from gas to solid. Okay, so give yourself a mark. Use a green pen to actually make your corrections. Okay, and again, pause the video and get to do that. Okay, moving on. Now we've been able to actually develop our knowledge. Now we're going to look at the different ways of showing the states. Okay, now what I want you to do now, okay, is I need you to show the state of the following things. Okay, inside this box, imagine the particles in the box, the atoms. Remember what we learned from last lesson, how we did modeling. So I want you to actually do this for me, okay? Draw it in terms of water freezing to ice, okay? Draw the state, and ice slowly melting, water in a kettle boiling, dry ice sublimating to carbon dioxide gas, okay? So I would like you to do that. Again, pause the video and carry out that activity. All right, let's go through the answers. Now, water freezing, okay, to ice. Remember, it's changing from liquid to solid. Remember, solid things are going to be together. The atoms are going to be actually squeezed next to each other, tightened next to each other, so they cannot move, okay? And that is how you should represent it. Again, pause the video and make those corrections, okay? The next one is an ice slowly melting. Ice, okay? That is actually changing state from solid to liquid, okay? And this is how you should represent your answers, okay? The next one, water in a kettle boiling. This time is actually changing from liquid to gas, okay? Now look at the change of state there. This is how we actually represent it. Again, if you got it right, make sure you give yourself a mark or make your corrections, okay? That's the most important thing, that you understand why you've done something wrong. And the next one, dry ice sublimating to carbon dioxide gas, and that is actually changing from solid to gas, okay? As you can see, the space is more free up, and the particles, the atoms, are able to bounce around and move around even more, if I'm making sense. Okay, now when a substance changes state, the particles stay the same. Okay, listen. When a substance changes state, the particle does not go anywhere. Okay, it stays the same. It's just the arrangement that changes. Okay, it's just the arrangement, if I'm making sense. Remember, the particle stays the same. It's just the arrangement that changes. It's very important for you to understand that. Now, we've been able to actually secure this knowledge, whether you believe it or not. Yes, we've been able to do that. Now, this is the 6 marks question you're going to do, okay? For you to explain in detail how the motion arrangement of particles affect properties of water in its free state. Now, before you do that, okay, now you're going to be marked based on spelling, grammar, organizing your ideas and information clearly, and using scientific words, okay? Now, before you actually do that, okay, we're going to get some help first, okay? First of all, what we need to do, okay, is in your book that you're writing, I need you to write down the properties of solid, liquid, and gases in 1 minute. So again, pause the video and write down this free state. This is what's going to help us. All right. You've done that? Brilliant. So the next task I'll ask you to do, now that is actually the properties of it. Again, if you haven't done it or done it properly, you can write this down. Pause the video and write it down. Now, the next task I'll ask you to do is, okay, what do we literally mean by motion and arrangement? 20 seconds, write it down. Okay. Now this is the next thing you're going to do, okay? Choose one property and explain it in terms of motion and arrangement, or both, okay? For 30 seconds. Again, pause the video and attempt it. Okay. Now, here's that question now. Okay? Attempt to answer the question. Okay. Now, this is what your answer should literally look like, okay? You could write down ice, liquid, water, and steam and explain it based on their properties, okay? And this will actually earn you 6 marks, okay? 6 marks question. Now, what I'm going to be doing next is actually, now, interesting enough, this is what we've done. We've finished it, okay? But we're going to be actually looking at some examples, some things to explain it further in the second part of this video. So once you're done with this particular video, make sure you jump straight into the part 2 of this video, okay? And I'll see you in the next video.